Speed is not about horsepower alone. It is about resistance. The Koenigsegg Jesko Absolut is engineered for one purpose: to chase a top speed beyond 330 miles per hour. To do that, it doesn't just add power, it removes drag. At extreme speed, aerodynamic drag becomes the dominant force. Drag increases with the square of velocity. Double the speed, and resistance doesn't double. It quadruples. That means pushing from 250 miles per hour to 300 miles per hour requires dramatically more power than accelerating from 100 to 150. The Jesko Absolut uses a twin-turbocharged 5.0-liter V8, producing up to 1,600 horsepower on E85 fuel. That power feeds into Koenigsegg's Lightspeed transmission, a 9-speed multi-clutch system capable of near-instant gear changes without a traditional flywheel. More power means higher potential speed. But without aerodynamic efficiency, horsepower becomes waste. Unlike the track-focused Jesko attack, the Absolut removes large rear wings and aggressive aero surfaces. Every exposed aerodynamic element increases drag. So the Absolut smooths its body lines, reduces turbulence, and lowers its drag coefficient. The car is engineered to minimize air disruption. Even side mirrors are eliminated in favor of cameras. The rear body tapers to reduce wake turbulence. Underbody airflow is optimized to reduce lift while keeping resistance minimal. Because at 300+ miles per hour, lift becomes dangerous. Air passing under the car can create upward force. If lift exceeds tire grip and vehicle weight, stability vanishes. The Absolut's long tail design helps maintain aerodynamic balance without large drag-inducing wings. But drag is not the only limit. Tires become the next barrier. At 330 miles per hour, rotational speed is extreme. Tires must withstand centrifugal forces trying to tear them apart. Heat builds rapidly. Rubber compounds must balance grip with structural integrity. Even if the engine produces enough power and the aerodynamics allow stability, tire technology may define the ceiling. Then there is gearing. The Lightspeed transmission allows rapid gear changes without interrupting torque delivery. That maintains acceleration efficiency. But gearing ratios must match engine power band and aerodynamic resistance curve. Top speed is achieved when engine power equals aerodynamic drag plus rolling resistance. Beyond that point, additional power only compensates for losses. And then comes rotational stress. At extreme RPM under sustained load, internal engine components experience enormous forces. Pistons connecting rods, crankshaft, and turbochargers must survive continuous high-pressure combustion cycles. Twin turbochargers compress intake air, increasing cylinder pressure. More pressure means more force on internal components. Thermal stress multiplies. Cooling systems must dissipate heat efficiently. Oil lubrication must remain stable at high temperature and high rotational speed. Mechanical failure at 300+ miles per hour is not gradual. It is catastrophic. Fuel also matters. On E85, higher octane rating allows increased boost pressure and ignition timing without detonation. That increases peak power. But fuel consumption rises dramatically. Range becomes secondary. The Jesko Absolut is not built for comfort, practicality, or traffic. It is built for a narrow envelope where drag is minimized, power is maximized, and mechanical integrity is pushed to its threshold. The target is not acceleration, it is equilibrium. At top speed, forward thrust equals total resistance. Every design choice, body shape, transmission, engine tuning, tire selection, is calibrated toward that equilibrium point. And physics does not negotiate. Air density, temperature, and altitude all influence performance. Cooler, denser air increases drag but improves engine combustion. Warmer air reduces drag but decreases power. Environmental conditions can determine success or limitation. The Jesko Absolut represents what happens when engineers pursue top speed without compromise. But it does not escape constraint. Drag increases exponentially. Tires approach structural limits. Engine components endure extreme stress. Cooling systems fight thermal saturation. Beyond a certain threshold, speed is no longer about adding horsepower. It is about overcoming resistance without tearing the machine apart. Because at 330 miles per hour, the enemy is not traction, it is air.